Yesterday, Saturday, was a very good day. I went to my favourite boot sale, and what turned up? A beautiful Variac, current 10 amps, type 72A. This is one made by the rotary Regavolt, made by the Berco company. Look at the top. It's manufactured by the British Electric Resistance Company Limited. And if we look on the other side, it'll be upside down. Don't know if you can see that. No, I don't think that has come out very well. But I'll say where it was made. Well, let's have a little go first. That might light it up. That might throw some light on it. And in fact, what it's done, it's allowed the name to come around a bit further at the back. And as we can see, it's Queensway, Enfield, Middlesex, England. Well, for quite a while now, I've been doing the odd video on certain lamps using a much smaller one of these, and always said, oh, I can't wind it right up because the wattage of whatever I'm putting on would have been too high. Well, I'd always promised myself one of these, and when you go to a boot sale, you must never go there saying, I've got to pick up a so-and-so. It will not turn up. And as you can imagine, the last thing I thought was going to turn up today was one of these. As I say, it's 10 amp. It's a good beefy arrangement. It's got the socket on it and the input plug all wired in. It's what is called an enclosed type. So there's no bare wires being exposed. We can look inside if I can get the light on. See if we can see the windings. As I say, they're good hefty windings. Let's just about see them in there. Obviously at a boot sale I can't sort of take the thing apart and have a look at it, but the gentleman that I got it from I've known for quite a few years, and his stuff is always good. So I said to him, how much is it? He said it was £30, it's now 25. So I took the money out of my pocket and said thank you very much. These on eBay and places like that are over £100. They're more like £150. I didn't realise they were quite that dear, but that's the kind of prices they're fetching. So to get one for that silly price, I said right, let's go for it. Anyhow, as I say, it's what they call an enclosed type. Some of these you buy are for sort of chassis mounting, where the coil is all exposed. With this it's not, it's nicely covered in. The amount of holes is for the heat to escape. Not that this one's going to get that hot, but that's the reason there's holes in it. Now the top is graduated in, it goes from 0, let's see if we can get it on there, 0 round to, on the other side, 110. Now that is percentages. So if we're reading a voltage, I'll make it easy. Say we're plugging into 200 volts. The theory is that if we turn this round to read, and the light's going dim, 50, we're now reading 50. So in theory, if we're pushing 200 volts in, we should be getting 100 volts out. The reason they don't do it in volts is because the input voltage can vary. So it's no good saying it's such and such a voltage. You can't tell. It depends what the input voltage is. And as the mains can vary, it's approximately 220, but it does vary. By doing it this way, you get a better idea. Now, what I did was to get a little meter, a little voltmeter, put it onto AC volts, and write down the main points where you might want to use this. These are a very, very handy tool. The name Variac comes from the name variable AC, and it was an American firm that started up. Now the name has sort of come to mean any type of variable transformer. As I said, this one's made by Berco. It's a rotary regavolt it's called. Anyway, what I did was there's the 10 volt stop, 20 volts, and so on. We've got 50 there. Now after 50 I thought, well, the next big step is probably to 100, 110. So there we'd be getting 100 volts out. Here we're getting 150. You can see the light getting brighter and dimmer which way we turn. Now we'll carry on turning. Now normally the maximum voltage would be slightly higher than the voltage going in, but in this case it isn't. In fact, it's virtually the same as the mains voltage, but I'm not too worried about that. There's 220 there, so you know, if anything, we don't want to push too much above 220, I can stop it there. Right, what else can I say about it? It's very heavy, and this one will be going into the workshop and stand on the bench. Now, uses of these are quite many. Old vintage radios. This is the normal one that people quote. An old radio that's been not used for many, many years. Certain components don't necessarily break down, but they get tired. The capacitors get tired, they get dry. Other things, resistors, they might get a bit dodgy. So the best way, if you've got a set which you're putting on for the first time for donkey's years, put it through this. If it's supposed to be on 240 volts, gently wind it up. Don't just whap on the 240 volts straight off. That could blow any capacitor, which is a little bit that way. So start it up, let the valves gently warm up, and if you bring it up over a period of a little bit of time, you give the radio a better chance. That's just one of the reasons, the uses. Other uses are obviously to wind up a certain voltage, remembering it is AC, so if it's got to be DC, you've got to rectify it. Precautions. Yeah, obviously I'd make sure the casing is grounded. This is on a 3-pin plug, so it's automatically grounded or earthed. Used in a ventilated area, so if you do overrun it, well, I don't advise you overrun it, but it has a chance to cool down. This one, as I say, is rated at 10 amps. So get the actual wattage. If you multiply 10 by the voltage, you will get the total watts. So if you call it 200 volts with 10 times 200 is 2000. So it gives you the rough guide to the kind of wattage that you can expect to get out of this. 2000 watts sort of represents a 2-bar electric fire. They do make these larger, but this is quite sufficient for what I use. And as I say, it won't be used all the time. I shall still use my small ones when we're doing small testing and that. Anyhow, I think I've more or less covered all about these. I know a lot of people talk about these, and bulb collectors certainly like to have these because you can gently wind the voltage up, and that way, fortunately, you won't blow the bulb, or there's less chance of blowing the bulb. Alternatively, you could use a normal dimmer switch. Works on a totally different principle, but the result's the same. So if you have got a delicate bulb which you don't want to blow up, but you do want to show it off, a light, then I'd certainly recommend either one of these or the good old light dimmer. I know a company in America called Leverton. They made one of their holders, it's a medium screw holder, with a built-in dimmer and a little knob out the side which you would turn, and that would control the brightness of the lamp. So I'd certainly use one of those. Anyhow, I think I've finished gabbling away. Any questions? Ask. I'll try and give the answer. One thing I would mention before I go, with this type of transformer there is no isolation. This means that it is possible down to ground, and on one of the leads out you could get the maximum voltage, because the single winding acts as primary and secondary. So, you know, if isolation is required, these are no good unless you then put it through a one-to-one transformer, which will give you isolation. But I mention this because, you know, you're dropping down from 220 volts, which would give you a nasty shock, to a much lower voltage which you'd think is perfectly safe. But remember, that down to earth could be the maximum voltage. Anyhow, I've talked for long enough. Probably sick of my voice by now. I would say thank you for watching. Any questions, any answers, any mistakes I've made, let me know. We're all learning. So I will shut up now and say thank you for watching. Please subscribe. Thank you again. Thank you.